Hello everyone and welcome back to this channel. Today I'm going to talk more about today I'm going to speak about what is backface detection algorithm. But to start with this video, first we need to know what is meant by backface in any image. So this is an example of a squirrel sitting on a tree. You can see the one eye of squirrel, one ear of squirrel only, and some little portion of the squirrel's other ear, his body, tail, but we can't see the other side of the tail, and some part of his this feet and the whole of this feet and this feet and the tree's bark. But what we are looking at this image, what we are possibly able to look at this image is the front face for us, but the tree bark's back, which we are not able to see, is known as the back face of this tree. Actually, you know that this tree is wholly a 3D object, which is much more like a cylinder, but we are not able to see but we are not able to see all the sides of the tree at the same time, and we are not able to see the whole of this ear as it is as we can see in the 2D in the front of it right now, that only this upper portion of this ear, but the lower portion, which is also very much similar like this ear, is not we are not able to see in this image. So this part is known as the back face of the image of the object's back face of the object in any image. Basically the face which we know that in an object is there but not able to see at the current image is known as the back face for us. But yeah, here we know that cube has six faces, but at the same now, right at the moment, I'm only able to see the three faces of the sphere only. So the other three spaces of the cube is hidden. So those hidden surface is known as the back face. You can see in the 3D axis that this is X, Y, and Z 3D axis, and the person I is here the viewer. So I'm going to explain some of the terminologies which we are going to need for this algorithm to understand. The vector v which we are able to see is the direction of our eye, where our eye is situated to see the object, and this xyz is the 3D world coordinate, and this small n normal you can see is the normal to the to this particular face which we are not able to see right now in this image, the normal to this plane surface, this surface which is identical to the back surface, and normal to this plane is the n surface, and by convention we consider the direction of normal of the plane is coming out of the plane. We generally take this as a convention that any plane's normal is coming out of the surface, which will be denoted by small n. The small n which we are going to denote, actually all the six faces will have different different normals. All the six faces will have, but the small n which we are going to talk about is going to be of particularly of only the back face says normal. You can understand more clearly in this image. Here all the surfaces normal is drawn with the red arrow. The small triangle type of thing of this gem, this small triangle is one plane surface of this whole 3D object, and this red line is the normal's direction for this small triangle's plane direction. And there are multiple plane direction of there are multiple small spaces, small plane on this 3D object and they have different normal direction. But this image is basically depicting why do we need to find the back face of any 3D object in an image. This person is the viewer, and this purple arrow is showing how the viewer eye is looking at which part of the 3D object. So the viewer at a time is able to see only these parts of the gem and not which is at the back of this gem. It is physically there, and this information is getting stored to our computer as the definition of this object. But the point is, at the moment, I'm only able to see these surfaces only by the viewer when I'm looking at the 2D image of this gem. These shaded portions, and we are not able to see in the 2D image. So, for lesser computation power utilized for producing any image, digital image, these informations are neglected out to save the computational power of the computer and to process our and make our digital image at a faster rate. So this information is redundant at a particular time. So for that reason, we need to find which part of the 3D object and in any digital image we are not able to see. It's very crucial to understand. One thing, first I'm going to explain what are where the basics of any plane. We can understand that we are trying to find which plane is facing not facing along this viewing direction. We will talk about it later, but first I'm going to again revise what were the basics of description for any plane in any 3D geometry. So basically you might have all learned how plane is described in a 3D plane. 3D world coordinates, how a plane is described, but we are revising it again here because this is very crucial because these were are the criterias for our understanding. These are the criterias on which we will find whether this any plane surface is the back face or the front face. So first of all, this for example is a blue colored plane, and this is the origin x, y and z direction. You can see that the positive z direction is normal to this plane and the plane equation is z equal to 3. How we generally describe a plane's equation in a 3D geometry. A plane is simply depicted, generalized formula for plane is ax plus by plus cz plus d is equal to 0, which where constant a capital A, B, C and D are constants. And in this example, we have only A, B and D equal to 0. A, B is equal to 0, C is equal to 1 and D is equal to minus 3. Because Z equals to 3 is written, to compare we have to give Z minus 3 equal to 0. So how do we understand by this equation that any point is on this plane or is above or below this plane? If the point is on this plane, suppose 003 is on this plane because we know that we can see the red dot is on the plane. So this point must satisfy this equation, that is it must produce uh, z minus 3 equal to 0 as 0. So if we keep this point on the plane's equation, x equal to 0, y equal to 0 and z equal to 3. So 3 equals to 3. This equation is satisfied. So this point is on this plane, and how in general form it is said that ax plus by plus cz plus d will be equal to equate to 0 if this point is on this plane. But what if this point is above this plane and along the positive z direction? Then what should be this equation's value? Then ax plus by plus cz plus d must be greater than 0. And how I'm saying that it is greater than 0? We will see in just a moment, or just recall that how equation of a plane was made. We How we can define a plane is that by having a vector which is along this plane and another vector which is perpendicular to this plane, and their dot product must be equal to 0, as nine two vectors which are at angle 90-degree, their dot product is 0, because if we shadow it on that vector, if we say suppose this is the vector, say if we imagine, and this is the normal vector direction, if this vector's shadow is formed by a point on this arrow, so that is why the dot product is saying that it is 0, that no component of z is along this planes along the direction of this plane, or along the direction of this vector which we took. And if I take some point which is above, which is along the z direction, then we might get some component of this z vector along this uh, point, this vector, which is above and along the line of this z direction. Either I transform this vector on this z axis, or the z axis on that yeah, on that vector which we have taken. But either way, both way, it depends on which vector is being transformed according to our need. The dot product will be more than 0, which means that it makes an acute angle with the positive z direction. And if this point is below this plane, which means that negative direction of this z axis, then the dot product will give us the dot product will give us a negative value, because the angle made is obtuse, which means that this point is below this plane. So ax plus by plus cz plus d will be more than 0 if the point taken is above the plane, and if the point taken is below the plane, we'll have the value ax plus by plus cz plus d less than 0. I will give a link of a video which will explain it in more 3D manner. Here I'm not able to describe it in words very much properly. If you all like to see that video, I will uh, pin that video. I will give the link of the video in the description box, and you can see how this equation of plane was valid, and recall that how equation of plane was made in the first place, and how I'm saying these two values should be. What these three values should be, three conditions any point can be with respect to this plane. So let us now see how this is relevant with our backface detection algorithm. Let us move back to this image. Here you can see the plane surface. This plane surface is the front face which this viewer can see, and this plane's normal is making an angle of 180 degree with the viewer's direction vector. So this means that dot product of the 90-degree angle, the dot product of this perpendicular of the planes, the 90-degree vector which is perpendicular to this plane, and the viewer vector dot product must be less than 0, as it makes 180-degree angle, which means negative dot product, that is they are in opposite direction. And this implies that this plane is the front face which we are looking at. You can see that this vector's angle, which is also visible, this surface a perpendicular vector makes an angle which is also not equal to 180-degree, but still an obtuse angle. So we can see this plane surface as well, and this angle, this similarly, this face and this face, all these faces are making obtuse angle with this viewer's vector and the viewer's vector and the normal of the plane. So their dot product must be less than 0 to say that these faces are front face. Then which faces are the back face? The viewer's direction, the viewer's vector direction is in this manner, and the one which are shaded as the back face, their normals and their normal vector and the viewer vector angle is actually made of is making acute angle which is less than 90-degree or equal to 90-degree. Then the face is at the back face. So the criteria is that the angle made by the viewer vector and the direction of the normal of the plane surface must make acute angle, or that is from 0 to 90-degree. Then the face is declared as the back face. So this is the what is known as the inside out test, which can be implied both of the ways by ax plus by plus cz plus d equal d value d's equation. If the point is on the plane, equation evaluate to 0, and if the point is above the plane along the normal, point is looking at the back face. So ax plus by plus cz plus d is more than 0, or you can say dot product of v and n is more than 0, which implies viewer is making acute angle along the normal of the plane, and which means that this is the back face. And if the point is below the plane, what if the point is below the plane? It means that point is anti-parallel with the normal, that is ax plus by plus cz plus d is less than 0, which implies viewer is making obtuse angle with the normal, which implies that we are looking at the front face. Yeah, we are looking at the front face. So the point is either inside the volume of this whole solid, or we can say we are not going into the volume as this object is not transparent. So we can imply that we are looking at the front face, that the point is on the surface of this object. We are not thinking of the case that this object is transparent and we can see inside volume as well. We are looking mainly for the surface of the point. So we are considering that this point is on the surface or on the front surface area. So that is all from today from my side. Thank you all for watching this video till the end. I hope that I almost made the point which I wanted to make clear to you. That's all from today. Thank you for listening till the end of this video. If you all like this video, then please hit the like button. If you all love this video and want to hear more such content from our side, then click on the subscribe button. Thank you and have a nice day and stay healthy, stay safe. Goodbye.